Okay, we're in section 3 of the notes, and this is, let's see where we're at. We're going to do the examples now. Again, lecture, typically quite short, examples to reinforce what has been taught in the lectures, all right? So let me go to the examples now, and I'm going to go to the whiteboard to do it. Give me a second to do so. Okay, so these, of course, notes are prepared for you. And by prepared, I mean that I'm not showing you my chicken scratch doing the problem, but certainly I'm going to show you what I would do before I would type this up. All right, so if I were given this problem over here, the first thing I would do is I'd say, it says find the area of the region enclosed by these graphs over here. I would get a visual for it. Now, suppose the visual is right there. Why would you need to get a visual for it? I need to learn. So for me to get a visualist over here is, there's two graphs for me to put down. I'll write them down for you. One is f of x equal 20 plus x minus x squared. And the other one is g of x, that's g. And what's that equal to? X squared minus 5x. Now, again, if I were graphing these things over here, the first thing I would do, clear as day to me, the f of x goes down, the g of x goes up like this. I know they're parabolas. All right, so my concern over here is, where do they meet each other, or do they never meet? So let's write this down. I'm going to say, when do they meet each other? In other words, when does f of x equal g of x? I don't know. Let's put this down. 20 plus x minus x squared equals x squared minus 5x. Well, I got to do this, right? So this is going to be 2x squared. Let's see, minus 6x. And then minus 20 equals 0. And I'm trying to find the points of intersection. Where'd you learn this technique? In Math 119. All right. So I'd factor a 2 out. This would be x squared minus 3x minus 10. This should be x and x. This is my chicken scratch on the side, by the way. And then I'd say, well, they meet where? Let's see. I'd say 5 and 2, right? And that would be minus 5 plus 2. And let me see if that's true. X times x squared minus 3. Yeah, it looks good. So the x would be minus 2. And the x could be 5. So what's the point going to be? Minus 2. Either equation is fine. I'd probably choose g to do it because g is so easy. That would be minus 2 would give you 4 plus 10, 14. And then I put 5 down. What would that give me? 25 minus 25, which would be 0. So what do I know? I know where they meet. All right. Now someone says, you're going to do a really good picture. Not necessary, but I know they meet somewhere. So where do they meet? Well, one looks like this, and the other one looks like this over here. I'm going to put this over here. And by the way, I don't care how bad the graph is. I'm going to put this down. This is going to be, well, this does look pretty bad, doesn't it? So I'm going to cross that out, put another graph down for you. I'm going to put it something like this over here. I'm trying to feel for it. I'll look at the better picture later. This should be 5, 0. And what's this over here? Minus 2, 14. And what's the area they're looking for? This area right over here. All right. Again, I'm going to look at the key later, but right now I am ready to put my integration down. And why is that? I'm basically looking at a nice little rectangle over here. And I'll put this, that's my rectangle right over here. And I'm going to put it down now for you. So it's going to be a dx problem. And where am I starting? Well, it looks like I'm starting at minus 2, going along the x's, and I'm stopping at 5. What's the upper curve? Well, the upper curve is going to be that downward parabola, which is 20 plus x minus x squared minus the lower curve, and that's going to be x squared minus 5x. Again, I'll look at the key later, and they're going to have much better pictures, and going to be all typed up for me as well. And it's going to be minus 2 to 5. Let's see, what would you get there? You would get 20. Let's see, you get x plus 5x is 6x minus x squared minus 2x squared dx. Well, again, if I can do arithmetic, I'm going to do it. So it's going to be 20x. I'm doing the antiderivative now. Plus, that would be x squared, right? Over 2, so 3x squared minus 2/3 x cubed, limit integration minus 2 to 5. Now remember, if you're weak at arithmetic, you probably need to walk away at this point. I'm not going to walk away though. I want to get the answer they have in the key. So what do you have here? 100 plus 3 times 25 is 75 minus, well, 5 cubed is 125. So that's 2/53. And yeah, I make mistakes sometimes. So I gotta be careful. It's gonna be minus 40 plus, let's see, that would be 12, right? And then it would get plus 16/3. Right? I want to do my arithmetic. It's gonna be, let's see, 175 plus 40. That's 215 minus 12. Let me see if I did it right. 100, 175, 215, 215 minus 12, 203. And then it's going to be minus 266 thirds. Well, I got to do the arithmetic now. 3 times 203 is 609 minus 266. And by the way, I'm not beyond making a mistake. Why do I do this though? We're trying to encourage you to do it. I mean that. So let's say 334 right on the side and plus 9. And 334 plus 9 is going to be 343. Let's look at the key. If I make a mistake, you're going to see me do it again. Wow, look at that. By the way, nicely, neatly typed up. What I do, I did my work, I did my integration, I did a nicer picture over here. So I presented. Your goal in life is not to do chicken scratch. Your goal is to present your work. All right. Present a work so someone looks at it and says, yeah, I understand what they've done. Now, is all the chicken scratch down? No, but the chicken scratcher didn't decide for you. Everything looks good. Let's make sure the points of intersection I got right. I did say 5, 0. The other one, do you remember that? That was minus 214. Looks pretty good. All right. Let's do this one over here. Really the same story. And again, I know they give me a picture, but I'm not going to take their picture. I'm just going to do the problem. All right. So it's x equals 9 minus y squared. And the other one is going to be x equals 7. Well, I'm going to visualize. I know for lessons said, do I need to visualize? I can't say sometimes you need to be able to visualize what they're asking you to do. And they're asking for the area bounded by those curves. All right. So x equals 7. That looks like this over here. And then 9 minus y squared. Well, let's see. That's a tough one, right? That's a parabola. And that opens, right? So I got to do that. I got a 9 over here somewhere. That's going to be the vertex. And it looks sort of like this here. And what's the bounded region? Let's put this in. It's this region over here. I know what someone's going to say is, you give me the picture. Why don't I just look at your good pictures and just trust you on it? You need to do this yourself, by the way. Let's do these points over here. I don't know if they're necessary, but I want to do them. Well, the x is 7, right? That's pretty simple. Well, this point over here is going to be 9, 0. And let's see if I can do those points. So 7. So that would be, I'll write that down for you. So the x is 7, right? You get 9 minus y squared. So minus 2 equals minus y squared. So y would equal plus or minus square root of 2. I'll put that down. That wasn't so bad. What do I do now? I'm going to do my little rectangle. And the rectangle I'm going to put in is like this over here. I'm going to put my integration down now. And what's my integration going to be? It's a dy now. What's my y going from? Minus root 2 up to root 2. And what's the integration going to be? Oh, it's got to be in terms of y's, right? So I got to do this. And so the upper limit is going to be 9 minus y squared. Minus the lower limit. What's the lower limit going to be? Well, that's x equals 7, so it's just 7. I got to do my integration. Fairly simple to do. And again, I realize Probably looks like chicken scratch to you, but this is my work before I type it up. So let's see, it's 9 minus 7, which is 2 minus y squared dy. I can do my integration. This can be 2y minus y cubed over 3, limits integration, minus root 2 to root 2. And again, I'll look at the key later. So it's going to be 2 root 2 minus, I have to cube the root of 2, so it's going to be 2, because it's a square, and it's going to be 2 root 2 now. If you have trouble with arithmetic, you should avoid arithmetic. What's the lower limit going to be? Minus 2 root 2, and then it's going to be plus 2 root 2 over 3. Let me repeat, if you have trouble with arithmetic, you got to avoid it. All right, you should learn it though. I mean, it's going to be tough to move forward in life without being able to do arithmetic. I'm bad at it too, though. I'll be honest with you. 2 root 2 minus, that's plus 4. And then what do we get? Minus 4 root 2 over 3. That's getting interesting. Common denominator 3, 12 root 2 minus 4 root 2, which is 8 root 2 over 3. All right. Again, I make mistakes. I want to point out the lion's share of credit, though, is your ability to put down the integration and perform the integration. Maybe the arithmetic is a secondary characteristic of being successful, but it's not the whole problem. All right. So let's take a look at our answer. 8 root 2 over 3. My God, I got this one right too. This is good news. All right. Look at the next page. They provide a better picture for me, yada, yada, yada. All right, let's look at number 3. Number 3 says they give me a picture that's not properly scaled. No, let's write it down. So x equals sine 2y, and x equals 1 minus cosine of 2y. All right. So, I want to figure out the points of intersection, by the way. And by the way, someone says, well, they gave you the pictures. And I think I know the pictures at this point. I'm seeing the sine curve. I'm gonna color this for you. And the sine curve, well, it's going to look like this one over here. Just a sine curve. And by the way, someone says, oh, it looks really strange. Well, it's x equals, not y equals sine of 2x. I'm going along the y-axis now. All right, that's not so bad. And then I'm going to say this green one, which is over here, is this curve over here. All right, I see the area, but I got to get this point of intersections. Let's see if I can write that down. And it looks tough, right? So let's write this down. X equals sine of 2y, right? So I'm just going to set the x equal to one another. Remember, we're not going to give you things you can't do. All right, well, you know what? I'm going to say it's a really easy solution to this one up here. Y would equal 0. That's a really easy solution, by the way. All right, so if I did that, what do you get? You get 0 on the left side. On the right side, you get 1 minus, and that would be 0, right? I'm sorry, 1, right? Yeah, that's 0. That worked out beautifully. So I got 1 point. And what's that point going to be? The y would be 0. What's the x going to be? Well, take any of these equations up here. I'm going to take the first one. It's so easy. So 0, 0. By the way, the picture actually shows that to me, doesn't it? So that's 0, 0. Let me see if I can get this point, though. All right, because and the graphs helped me a little bit. So, where else would that happen? Let me write this over here. So sine of 2y would equal 1 minus cosine of 2y. And I realize this is tough. So I'm going to say, thinking about it, I'm going to say pi over 4. I even say, why are you using that nice number there? I think it's a nice answer. So what's the sine of 2 times pi over 4? It's a sine of pi over 2, which is 1, right? 1 minus the cosine of pi over 2 is 0, right? That worked out beautifully. All right, so I'm pretty good with that. So I'll put the pi over 4 over here. And what's the x going to be? Well, you look at this one. It's pretty easy. It's going to be sine of pi over 2, which is 1. So we got this point. Now what I have to do, I got to draw a rectangle in. I know both these equations are solved for x, so I'm going to, do upper and lower x's. I'll do like this over here. A little integration down now, okay? So my differential is dy. And where am I starting? Well, the y starts at 0 and it stops at pi over 4. What's the upper limit? Well, that's the red curve, right? What's the red one going to be? Sine of 2y. Minus the lower limit. I'm sorry. The upper curve is, the red one. The lower limit's 1 minus cosine of 2y. So it's going to be minus 1 plus cosine 2y. You know what? That doesn't look right. I got to clean that up. And if I were an exam, I would clean this up too. Okay, let's see if we can do this now. We have an integration here. Minus cosine of 2y over 2 minus y plus sine of 2y over 2. Limits of integration 0 to pi over 4. Mistakes happen. This is why you do homework. So you learn where your weaknesses are and you try to shore those weaknesses up by practicing more. So let's see, what would you get? Cosine of pi over 2, which is 0, right? Minus pi over 4. Plus, what would that give you? That would give you the sine of pi, which is 1. So 1/2. Minus the lower limit, which is 0. And that's going to give you what? Oh, they're going to give you the cosine of 0 is 1. So that's minus 1/2, right? Well, minus 0 and the sine of 0 is 0, right? I think I'm ready. I'm not saying I'm right. I think I'm ready to do the arithmetic. So it's going to be, 1/2 minus a minus 1/2 is 1 minus pi over 4. That's a fine looking answer. You can also write down 4 minus pi. All right, let's go to the key, see how we did. And what they got? I see the answer right over here. All right, I see the answer. So it wasn't that bad. All right, so the examples that we went through, hopefully they weren't too bad. But the bottom line is we just did a bunch of examples and someone's going to say, when do I get a chance to try? Well, you can try right now. What are you going to try to do? Try the next section. Try the examples. Do you understand what we taught you? Hopefully. Now, again, this is a repeat of what you also did in math 121. They're actually the same questions I give my 121 students. But the bottom line is you need to review and practice and you get better over time. All right. Thank you for paying attention and good luck.